taking this forward, now as a part of agenda, we have display can you Mr. Manideep Saha. I mean, he's really already very renowned person into construction domain when it comes to construct tech. He has been part of Autodesk, Bentley, Dassault, I mean, and so on. So I cannot actually say much about him. Let's just please invite him for the next session, and he's going to talk about what all is required and what all is going on in the construct tech solution. Dada, please. एक मिनट, कुछ स्लाइड चेंज कर देता हूँ. थोड़ा सा गड़बड़ है इधर. गड़बड़ ये है कि हर बार जाके चेंज करना पड़ता है. इसमें ये है नेक्स्ट का, ये है लेजर. ठीक है.
All right, thank you, and once again, welcome all of you to this event on transitioning from 3D BIM to 4D, 5D BIM. As Gaurav just introduced me, my name is Manideep Saha, and also our apologies for starting late, but that's Delhi. I was wondering whether to start as good morning or mitron. So maybe good morning is a better option because this demonetization and whatever is the news of the hour anyways. All right, so I think when we talk about this transitioning from 3D to 4D BIM, would anyone hazard a guess as to how old is 3D BIM as a technology? How long has it been there? Anyone? Pardon me? Not that long. Yeah, I guess it was all started with essentially Revit one when it was an independent company before it was acquired in I think early 2000 by Autodesk. So yeah, I would say about 22, 23 years for sure. Okay. How old is 4D BIM? Any answers? Yeah, you're almost there. All right. Yeah, so it's a decade-old technology. So, as we all are from this construction domain, from the real estate domain, from civil infrastructure domain, we keep dealing with a lot of problems that we're trying to solve, and therefore technology becomes imperative for us to adopt and adapt to as we move forward, as we look at more sophisticated ways of increasing our productivity and delivering the results better, making customers happy, increasing the gross margins of your own company, and so on and so forth. So a little bit about myself. I guess I will not spend more than 30 seconds. So one of the things that I would like to mention here is that I've spent almost about 30 plus years working with all these leaders in construction tech solutions, Bentley, Autodesk, Dassault, etc. And over the last 2-3 years, I have started helping organizations choose the right kind of technology, create an implementation plan, and also help them adopt technologies, which could be tech firms, which could be companies like yours, which could be the top 4, top 5, the advisory companies, and so on and so forth. In fact, one interesting project I've just finished working is one of the largest real estate projects in the world. I cannot name it because of NDA, where I helped them choose the entire spectrum of the construction tech solutions. Of course, I was with a lot of other people. And so it was a combination of 3D authoring tools, 4D, 5D, on-site project monitoring, connected data environment, and so on and so forth, including the backend databases. So little insight on how is the construction market doing today in terms of the growth. So the global construction market will grow by almost $8 trillion by 2030, and essentially driven by China, US, and of course India. And the volume of construction output will grow by almost 85% to 15.5 trillion by 2030, again led by China, US, and India, and these three countries will account for almost 60% of the overall global growth. And India is definitely one of the, I would say, a star player in terms of providing a new engine for global growth for construction in emerging markets. You'll be surprised to know that we are growing at almost twice as what China is doing in terms of the construction, although you hear about very large projects in China. All right, so as an ecosystem, as all of us here, be it a user, be it a technology provider, be it a service provider, all of us trying to solve some key problems, okay? Let's try and revisit some of them. The biggest problem, as we all know, is cost overruns. So let me quote some reports, a McKinsey report of last year, I think. It estimates that 98% of large construction projects deal with cost overruns of more than 30%. Reasons: poor cost estimates during planning phase, frequent design change requests, all of us will probably agree with this, and payment delays. Project delays in terms of delivery, the same McKinsey report says that 77% of construction projects are at least 40% late. Again, there are some reasons which are beyond our control, for example, weather, labor shortage, equipment failures. Some reasons which are within our control, for example, project scheduling issues, project conflicts, incorrect data, human errors, workforce management, and insufficient or improper scheduling. Inadequate communication amongst team members, disconnected off-site and on-site workers, between planning and design and construction teams. This has been a bane of the industry. We are getting there, but I guess it's still a problem that we are trying to deal with. Unrealistic expectations. Planners are usually, we have seen, are not on the field and are mostly unaware of the actual time being taken on the field or on site for all the tasks. They're just getting some data, they're entering into a Primavera or a MS project and getting done with that. Teams are uninformed about issues until it's very late, and there is no common data platform for sharing all the data between the stakeholders. Again, there are technologies, people are adapting, but I think we have I won't say a long way, but yes, we have a way to go there. Poor planning, forecasting, budgeting. Forecasting maybe focus too much on the long term, maybe not so much on the short term. Contingency planning is always an issue, and sometimes incorrect estimates in budgeting. Labor shortage. COVID obviously has had an impact, and there's a persistent shortage of unskilled labor and also skilled and qualified professionals, civil engineers, architects, etc. There's a lack of organized document management, what is being seen in most projects in terms of a lot of manual document management, which obviously is inefficient and prone to errors. Digitalization allows for better access, centralizing all important information. Cash flow is a big problem in terms of how efficiently you are managing your accounts payable and accounts receivable, which obviously impacts your overall project progress. And there are modern solutions that can ensure that all payments are followed through and accounted for, which are systemic rather than manually driven. And finally, I think this is a big problem we're trying to deal with as technology providers, is that most construction firms or design firms are still hesitant. That's why I use the word hesitant. They are not opposed, but they're hesitant to adapt and adopt to new technologies, which despite all the, you have so many use cases where people are benefiting, and I think that's where we have to drive this whole thing as an ecosystem. Let me ask the audience, do you see any other problems besides what I have listed as we, do our construction projects? Any other problems that we face? Okay, right. Is that a very India-specific problem, or is that a global problem? Any other?
Contractors are not equipped to deliver in way. Many of the contractors are not following well.
In terms of?
In India, in Indian context, apart from big names, there are very few contractors who work on well. And when they are asked to do that, they hire somebody
it's a stopgap kind of arrangement, and I think that's where the point of hesitation to use new technologies is there. They are only seeing the high upfront cost, but they are not seeing the larger picture in terms of higher productivity and efficiency. Right? You're absolutely right. Except the top 4, 5, and today we see that there is still a wrong interpretation of BIM as just make 3D models and you're done with BIM. So I think we'll do a deep dive on all those. So thanks for the inputs. I wanted to kind of take a very quick view. I will not go into details because some of these are actually covered by my colleagues in the later presentations. I will cover about 7 or 8 latest trends which are now coming up as latest as trends in construction technology. So first is of course BIM. I mean, I kind of contradict myself because BIM is not the latest technology, but nonetheless, as a industry, we are still adopting and learning about this BIM technology. So I would still say it's a trend. So first myth that we need to dispel, and I'm sure all of you will agree with me, BIM is not a software, neither is it a technology. It's a process. Okay? But I've heard so many people say, I've got Revit, I've got BIM. I've got Civil 3D, I've got BIM. That's not true. I think that's where we have to make that change at the base level. A building can be built through a virtual model even before its physical realization. I think that's the crux of BIM. The other big crux is change anywhere is change everywhere. Big difference between a 2D model or even a 3D model versus a BIM. UK was one of the first countries in the world to actually come up with a clear BIM strategy, and based on that, the ISO 19650 standards are laid out for BIM, and today most organizations are following this. And of course now we have a lot of popular BIM authoring tools, Autodesk products like Revit, Civil 3D, Bentley products like MicroStation, Open Roads, which was earlier MX Roads, Open Buildings Designer, etc. So now you have a bunch of products which can help you reach the BIM status. So some of the benefits of BIM, digital integration in terms of helping you streamline and collaborate with different teams and stakeholders, a single platform for visualization. It's a cost-effective platform because you can do clash detection, so you are basically removing the barriers of redesign or finding faults in design while you start the construction. And accessibility to information, basically all the processes are completely coordinated at each stage of the design, so you don't miss out anything, and change management becomes very easy and effective. Higher productivity, obviously, because if you do all this, you're obviously going to get a higher productivity. So a coordinated BIM model will have all the information regarding every change that you make, which gets reflected across the model. These are some of the benefits. I'm sure there are a lot of other benefits. I just wanted to highlight a few top. The next one, as you transition from BIM to 3D BIM to 4D BIM, is the new technology. Again, not a new technology, almost a decade old now, but essentially it's an effective tool for optimizing the construction process while providing a visual overview for all the stakeholders. This becomes very important as you're able to intuitively see how the project is progressing, matching the models with the Gantt charts, with the resource, the work breakdown schedules, etc., and you're able to actually see that all on one single dashboard. It can be used at different stages of the project, right from pre-bidding to handover. Obviously, it saves substantial time and cost for on-site and off-site projects. There are many use cases, but one use case I wanted to talk about is a project that Mott MacDonald had done using synchro-based 4D simulation for a pipeline project in the US, which saved them a clear 20 days. Now for a project of this size, a 20 days saving means millions of dollars. So some of the quotes: 4D modeling was crucial on a major civil project for United Utilities in Cumbria, proving and improving upon a challenging construction program that was 20 days quicker than the original plan. And that's something that I've been trying to, this came from a project manager of the project, that's something that I've been trying to stress to my colleagues when we have talked about 4D modeling, because people say, we don't want to get into that until we have done the design, which is typically the problem. And we want to know what we're building. you need to bring it to you need to bring it a bit further ahead before you actually do a design freeze. This is what these are things that these are the inferences that came out of this particular project. So this is an image of typically what a 4D collaboration looks like. So you have the 3D model on the right side, the BIM model on the right side, you have the project schedules, and you have the resources. So you have the entire dashboard in one go. Okay. Next big technology, digital twin. Again, digital twin is not new. Digital twin has been in the infrastructure sector for about, I think, about 5 or 6 years. But as a technology, as a process, it's been there ever since Industry 4.0 was it came to the market, which was essentially started with the manufacturing sector. You can go back as way back as 1999, when the first full digital model of the Boeing 777 was created, and a digital prototype was created. That was the first instance of a typical digital model, digital twin. Of course, then it was adopted by large factories. Then it was then now we are of course seeing this being adopted by large construction projects, be it in heavy civil, be it in real estate, and so on. So what is a digital twin? Essentially, it's a virtual model designed to accurately reflect a physical object. So you have a physical space, data goes from there into the virtual space, and you have the actual data coming back as an information back into physical space. So you're able to visualize and manage the project better, much better as you move from a design to a construction stage. So you're able to, even during the construction stage, you are able to integrate the building system using sensors and various other methods and utilities. So basically you get a multi-dimensional digital model. And in the near future, there will be fewer buildings with operational issues because you are able to monitor the entire performance of the building, even from an O&M standpoint. You can also do performance analysis. So for example, let's say large, with all the, issues about pollution control, etc., sustainability, etc. This could be very, very useful because you are able to control the parameters for managing the performance of the buildings or the infrastructure, as the case may be. The fourth big trend now is drone. Again, drone is not a new technology. It's been there for more than a decade now. In India itself, it's been there for almost 8 to 10 years. There are major players. But so far, what I've seen is drone technology is being used mostly in large-scale, either infrastructure projects or defense. And of course, you keep hearing this news every day for all the wrong reasons. For the drone carried explosives and ammunitions which come from the border across to India. But that's not what I'm talking about here. I am talking about drones as a technology for essentially being able to capture the data better, which can be used better in your design and construction phase for your infrastructure projects. So you are able to create a 3D digital model from all the drone data that you capture. So basically high-speed cameras are loaded and you are able to do it very fast as compared to a typical survey method or even aerial survey or LiDAR, etc. Of course, LiDARs are now available on drones also. So you're able to create a 3D model very quickly. Typically, it's almost 10x faster, okay, in terms of time and obviously therefore cost. Just to give you an example, maybe a little variation, but nonetheless, I could do a drone survey of a 20-kilometer road stretch, which could be a 6-lane or an 8-lane highway, and I could do it in about 3 to 4 days, right? Turn around the data, give it to you in 48 hours. So we are talking about a week. Whereas if I were to do a traditional survey or even using the mobile vehicles, etc., which are used for a survey, it will take you at least 15 days or more, okay? So you're able to get real-time imagery and 3D LiDAR scans, and you can also use 3D now scan to BIM mode on drones. So that's an additional thing on drones. Okay. And in 2023, as we speak now, you can expect more sophisticated and AI-oriented drones, including SaaS or cloud-enabled insights and analytics that you can get using the drone data. Okay. This is a typical image of a drone survey. for a urban development application. You can see the resolution. Okay. Now this is how you are integrating drone imagery with 4D. Okay. And if you see the note, a date, it is 2017, which means that it's been in use for almost 6-7 years. So on the right, you see a drone captured image of the actual construction site. On the left, you see the 3D model as per the current status. This is for a Middle East project. Okay. Fifth big trend is 3D laser scanning. Again, not a very old, not a very new technology. It has been there for quite some time. Very popular in the plant and oil and gas sector, but now catching up in infrastructure, civil infrastructure sector. So it can be deployed for on-site survey, reality capture of existing conditions, construction inspection and verification, safety inspection, design engineering, 2D and 3D laser mapping, prefab and clash detection. So it pretty much covers everything, except that it's a little expensive at this point. So in-plant infrastructure could be a real use case for this. Very high accurate and precision, and most importantly, the data that you get from 3D laser scanning can be fed into 3D authoring tools for either forward or reverse engineering, for as-built, reverse engineering, for new forward engineering. So a use case, a hospital in France, they use Faro, which is a brand, a very well-known brand of 3D laser scanner. And it was along with scan to BIM to capture every feature of the existing hospital, and a new model was generated for renovation, a very typical use case. Okay. The sixth big trend is AI and IoT. I have a colleague from RICS. Yeah, Dr. Vijay, I'm sorry. Yeah, so he will do a deep dive, so I don't want to steal his thunder. But nonetheless, a quick word, IoT devices, they collect massive amounts of data which can be integrated into dashboards. So contractors can easily visualize and forecast construction progress, productivity and cost in an integrated manner. AI-powered software applications can analyze these IoT inputs to provide real-time insights. And you can connect live data feeds from the IoT sensors to BIM and digital twins and leverage that information to create forecasting schedules and cost models. And IoT devices obviously can also report on changes in materials and environmental conditions. Okay. Integrated digital delivery as a concept started way back in mid-2000, and today we are actually seeing it happening. And this is where you see a lot of interoperability between different IoT devices, IoT ecosystems, and technologies like BIM, digital twin, and cloud computing in the near future. So that's where the entire integration is happening. We keep hearing this, virtual and augmented reality, or AR and VR. It's a very large business, almost $8 trillion is a global forecast. And they are promising to reduce the building cost by 90%. It can enable remote site inspection, especially where the sites are difficult to get to, and it enables safety, collaboration, and communication amongst the various teams. So Bentley Synchro is what we're going to talk about today, is one tool which can be used for AR, VR very effectively. Bentley has been working with Microsoft HoloLens and create this AR solution, where you can look at, in a very immersive kind of environment, you can look at the 3D. So you can see this guy on the left wearing this device, and he's able to visualize the whole thing in a virtual environment. And you can do a lot of what if and move this around and see how it works. So instead of a 2D screen with mouse and keyboard, you can now walk around the entire model with your body and reach out. So any movement that you do, you're able to do the visualizations. So users can actually walk through the model at one-on-one scale to compare details, record any differences, and directly into the model and measure the real-world progress. So any changes made to the model or any new task and resource statuses are added directly to the Synchro model once they are submitted. But a word of caution, HoloLens is still in its infancy from an equipment standpoint in India. Yet to get there, but probably in the next 2-3 years, definitely available. That's about all that I have to present. So feel free to reach out to me. These are my coordinates. And of course, the GKC team can also be reached to if you want to get back to me. Thank you very much. Thanks for your patience.
Thank you, Dada. Just please, Dada. So I would like to invite Dr. Shumank, he's an IIT research fellow, to just a small token of appreciation, Dada, for you. Please. Yes.
My token of appreciation will be when all of you start using protein.
Of course, sir, they will. Please.
Thank you.
Dada. Thank you, Dada, for those great insights. And